Here we have an example of memory expansion. We want to use 64K by 8 RAM chips together with a decoder in order to construct a 512K by 16-bit RAM. So basically we want to increase the width and also increase the number of the memory elements that we will have for our memory. So this is what we are going to use. Here we have the 64K by 8-bit RAM. There are a couple of inputs, one output. The output is the data output with 8 bits. We have the address input. For the address input, we will have 16 bits. We have the data input. Data input will have 8 number of elements. Then we have the read-write and the chip select. So this is indeed our small, let's say 64K by 8-bit RAM memory, and we are going to use a given number of it in order to construct a 512K by 16 RAM. So since we want to increase the width 2 times, we are going to have the chips in 2 columns. In terms of the number of rows, we need to determine the number of elements that we want to have. 512K, if we divide it by 64K, this will give us 8. So we will have 8 rows. And we have 2 columns. So 8 rows, 1, 2, 3, 4, 5, down to row number 8. They are now identical blocks, 64K by 8, all of them. 64K by 8. Well, for the chip select, we need to connect the chip select inputs of the ICs at the same row to each other, so they get selected at the same time. In terms of the read-write, the read-write input, they all should be connected to each other indeed. So I just show it in this way. All the read-write inputs are connected to each other. Read-write, I hope you can read it. Then we have the address and data in. In terms of the data, let's focus on data out and data in. The data out of all the memory elements, all the memory ICs, in each column will be connected to each other. Because we are using the 3-state bus here. And then we can combine them with each other. This will give us the 8 bits. This side will give us 8 bits of data, and in total we will have 16 bits of information. For the data in, similarly, we will divide our main data, which has 16 bits, into 2 parts. Eight bits will go to the first column and 8 bits will go to the second column. So each one of these buses have 8 bits. In total, our data in is composed of 16 bits. The most important part here is regarding the addressing. We know that each one of the ICs receives 16 bits for the address, and we need to refer to each one of the rows as well. So for that we need to have, for 8 rows we will use 3 indeed address lines, 3 additional address lines, and in total we will have 19. So 3 address lines and 16 address lines. These 3 address lines will be fed into a 3 to 8-line decoder, while the remaining 16 address lines will be connected directly to the address input of all the ICs. We will get 8 outputs from this 3 to 8 line decoder, and then each output will be connected to the chip select input of a single row. So we can say that this is what we have for the first row. For the second row, the second output from the decoder will be connected, and the last output of the decoder will be connected to the last chip select, to the chip select of the last row. The remaining 16 lines of address will be connected directly to the address input of all the chips or all the ICs. I hope it is clear for you if I do it in this way. So they all are connected to each other and to the main address lines. The 16 address lines that we have here will give us A0 till A15, and the other three will give us A18, 17, and 16. So in total we will have 19 address lines in total, which then gives us the possibility to choose among 512K memory elements. So you can see that in this way we expand the size of the memory, both in terms of the width and also in terms of the number of the elements that we can have. And over here you can see it again. So this is basically the same solution. You can see the address lines here. 0 to 15 are connected to the address input of all the ICs. In terms of the data, we have data lines 0 to 7 and 8 to 15 for each column separated, and also the data out in a similar way. So the least significant bits and most significant bits are separated at the input side, and then they are combined at the output side. And you can see how the 3 to 8 line decoder is used here, referring to the address lines 18, 17, and 16. And again, you can see that the chip select inputs of two ICs in the same row are connected to each other, and then they are connected to one output of the decoder. So in this way we can expand our memory.